Hi everyone, today we are going to be talking about scientific notation and rounding. You've been doing rounding ever since you were in elementary, so it should be pretty quick for you. Just reinforcing that the first spot behind the decimal point is the tens place, then the hundredths, the thousandths. We'll also use the ones, the tens, and the hundreds in this course as well. So these are the rounding rules. They are on your worksheet that you can be looking at as well. It says you look one place value smaller than what you need to round to. So if you're rounding to the ones place, you have to look at the tens place. And I think you've been doing that ever since you were little. So in a number like this one right here, if we need to round to the ones place, that's where that 3 is. We have to look where this 4 is to see how we got to round. See if we got to round up or round off. If this number right here is a 4, 3, 2, 1, or 0, we round off. So 123.4 turns into simply 123. And if that place value is a 5, 6, 7, 8, or 9, so this would be my example right here, then we would round up. So the basic rule is 5 or greater, you round up, less than 5, you round off. And again, I think this is stuff that you've done ever since you were in elementary. On the back of your front cover of your unit pack, it goes through the rounding rules right here. It goes through a couple of examples right here and another couple of examples right here. So we're not trying to hide anything from you. So let's round these numbers to the tens place. So what I want you to do is to pause the video, try it, then watch and see what the answer is, then pause the video, try it, and then turn it back on and watch and see what the answer is. But I'm just going to zip on through this. So if you're not pausing the video at all, you're going to get very little out of this. So we get around to the tens place. So this is my tens place number. So I look at the hundreds place number to see how to round it. That hundreds place number is greater than 5. So this is 9.5. I'm rounding to the tens place. So I look at the hundreds place. And the hundreds place is a 4. I do not let this 9 influence what is in the tens place. I could imagine that this 9 is not even there. So this one would be 88.5. Again, going to the tens place, so we look at the hundreds place number. These 9s have no influence on how we are going to round. So this one is 7.4. Same thing here, we are going to the tens place. So we look at the hundreds place. The hundreds place is greater than a 5, so the answer to that one is 5.5. All right, now we're going to round to the hundreds place. So same rules. Pause the video, try the problem, see if your answer is correct. So we are rounding to the hundreds place, that one right there. So we look at the thousands place. It is greater than a 5, so we round up. 10.49. We look at the hundreds place again, and we look right behind that, the thousands place, that is greater than that. So this is going to round this number up, which is going to round this number up. So we end up getting 7.5, and a lot of you will stop right there. But if we're going to the hundreds place, we need to have a number that goes to the hundreds place. All right, so again, we are going to the hundreds place. So we look at the thousands place. It's 5 or greater, so we round up. 0.01. And same thing with this problem. We are going to the hundreds place, so we look at the thousands place, and that is a 4. We do not allow the rest of this to influence us at all. So it is 0.01. All right, now we're going to do scientific notation, which is a little bit different. Scientific notation involves this times 10 stuff. And in this instance, we have a -2. And we have this times 10 stuff, and here we have a +3. So that's what scientific notation is. So these are the rules of scientific notation. I'm not going to go through them step by step, but I'm going to tell you how to do this. So we know this is the answer already. So the first thing we do is we need to put the decimal behind the first non-zero number. So any 1, 2, 3, 4, 5, 6, 7, 8, 9. We put the decimal behind that, but we cannot put the decimal behind a 0. So we write that out, 1.23456, and then we go times 10. That's part of scientific notation. Now, how many spots did we have to move the decimal? Well, I go 1 loop-de-loop, 2 loop-de-loops, 3 loop-de-loops, 4 loop-de-loops. So that's times 10 to the 4th. And this number is greater than 1, so it's the positive 4. So again, this is my answer right here, and that's how I got it. I'll do some more examples for you. Before I do that, on the back of your front cover of your unit pack, it goes through scientific notation, explains what it is, and gives you a couple of examples. This one's with a negative exponent, this one's with a positive exponent. On the back of your periodic table, lower left-hand corner, it goes through the rules of scientific notation. So when you're taking a quiz today or maybe tomorrow, those rules are right there for you. So here we go. We got a couple of examples on the board. I'll go through them one more time as to how did we get this for an answer. So we look at this problem, and we have to put the decimal point behind the first non-zero, so right there. So we go 9.8701 times 10. Very little thought goes there. Now how many spots do we move it? We moved it 1 spot, 2 spots, 3 spots, so that's where this coefficient comes from. And this number up here in our original number is smaller than 1. So numbers that are smaller than 1, that fall between 0 and 1, get a negative exponent. And that's how we went about solving it. All right, so I would suggest that you try these problems yourself. Pause the video, then play the video, see if you got it correct, and then do the next one, and so forth and so forth. I'm just going to zip on through them. So I need to put the decimal point right there. So I go 1.000 times 10, and I had to move it 1 loop-de-loop, 2 loop-de-loops, 3 loop-de-loops. And this original number right here is smaller than 1, so it gets a negative exponent. The next problem, I have to put it behind the 1. So 1.23456 times 10. Very little thought goes into this. Then I have to figure out how many loop-de-loops. Well, right here's where the decimal point is implied, even though this problem doesn't have any decimal points. I go 1 loop-de-loop, 2 loop-de-loops, 3 loop-de-loops, 4 loop-de-loops, 5 loop-de-loops times 10 to the 5th. Numbers greater than 1 are positive exponents. Numbers less than 1 are negative exponents. 9.8000 times 10. I have to move it 1 loop-de-loop. 1. And this number is smaller than 1, so it gets a negative exponent. I have to move the decimal between the two numbers. So 1.1 times 10, and I had to move it 1 spot times 10 to the 1st. This next one, I have to put the decimal point behind the first non-zero, so that's right there. So 1.2 times 10. And I have to go 1 loop-de-loop, 2 loop-de-loops, 3, 4, 5, 6, 7. And this number right here is smaller than 1, so we get a negative exponent. And then our last one, again, the decimal point's implied right there. I put the decimal point behind the first non-zero, so 5.01000 times 10. And I had to move it 1, 2, 3, 4, 5 spots. And that's how you do scientific notation. All right, convert these numbers to normal notation, how you would normally write out numbers. Well, what I like to do is look at this number and see that it's less than 1. So I'm going to throw some zeros out in front here and see what we have to do. So I have to move it 3 spots, and I have to make it a number smaller than 1. So I'm going to go 1 spot, 2 spots, 3 spots. So it's 0.009900. So again, this negative exponent right here says it's a number smaller than 1. If I would have went this direction with it, the number would have been greater than 1. Pause the video, try the next one. All right, the next one I see a negative exponent again, so it means it's smaller than 0. I'm going to throw some zeros out in front. I got to move this 1 spot, 2 spots. So this answer is 0.012346. Again, pause the video, try the problem. In this one, I have to move it so the number is actually getting bigger. So I got to move it 1 spot, 2 spots, 3 spots, 4 spots, 5 spots, 6 spots, 7 spots, 8 spots. So 1, 2, 3, 4, 5, 6, 0, 0, 0. And in this last one, we have another negative exponent, so that means less than 1. So I'm going to throw some zeros out in front. And I have to move it 1 spot, 2 spots, 3 spots. Oh, I got to move it 1 more spot. Oop. 1 more spot. So it's going to be 4 zeros in front. 0.000011. Let's check that out one more time. So if I was going to write this number in scientific notation, it'd be 1.1 times 10. And I have to go 1, 2, 3, 4 spots. And it's negative, and that's what they gave us to start with. The last thing that we have to do, sorry about that. Last thing we have to do is says numbers that are greater than 1 have exponents that are positive, and numbers less than 1 have exponents that are negative. So folks, right there is the work that you have to do. If you're at home, you need to complete practice quiz 4. Try to get a 90% or better. This goes into the homework score. Remember, you can take this as often as you like and earn up to 100%. Then we want you to take actual quiz 4, which is scientific notation, which is due in the next 48 hours. Remember, actual quiz 4, if you don't pass it with a 70% or better, you will have to retake this. All right, that's it, folks. Have a good day.